Hi, I'm Brian at AutoShopTeacher.com and on YouTube at Brian D. Wampler or BD Wampler. All right, let's get in today's topic. We're going to talk about the ASE A3 manual drivetrain and axles category. And more specifically, we're going to go through the 8 questions from the ASE study guide and see how we can work on these answers and what we come up with. But first, let's take a moment here and look at each of the categories in the A3 test. Okay, so you can see you're going to have about 6 questions that are scored for clutch diagnosis and repair, 7 each questions that are scored for transmission and transaxle diagnosis and repair. Then you're going to have 5 questions relating to drive shafts, half shafts, U-joints, and CV joints. And then you'll have drive axle diagnosis and repair around 7 questions, and then 4-wheel drive, all-wheel drive around 8 questions, for a total of 40 questions that are scored, but you will have 50 questions that you will have to take because of the tested test questions that ASE includes in the A series, meaning Automobile Series test. You won't know which of the questions that are not going to count against your score or in favor of your score. So you just want to answer every question to the best of your ability. You'll have 50 questions and 1 hour to answer those questions. So the math on that works out to be about 1 minute and 12 seconds per question. So the ones that you answer in maybe 15 or 20 seconds, that is great. Other ones where you need to think it through and use some of the techniques I'm going to share with you as we go through these 8 practice questions, well, you'll have the extra time if you need a full minute or 2 on other questions. And you do have the ability to mark certain questions, and if you have time left over at the end to be able to go back and review those questions. Just be careful about doing that. If you go back and review a question, make sure you're dead certain you want to change your answer, because most often your first selection was the right one. If Spanish, Espanol, is your primary language, on the A series test, again, that's Automobile Series test, you do have the ability to click a button and take the test in Espanol. So let's get into this. The first question here from the samples. Excessive brass filings are found in the fluid of a manual transmission. Which of these could be the cause? Loose main shaft bearings, loose counter shaft bearings, worn blocker rings, or broken input shaft gear teeth? All right, so whenever you're going through an ASE test question, the information in that one question needs to be fully examined because it can give you great hints. Okay, so we can see the big hint here that I've highlighted is that it's brass filings, okay, and they're being found in the fluid. So most likely there was noise, or maybe it's just a maintenance service and the fluid ran through a strainer. Handy thing are those paper funnels that you can get at the hardware store to be used, with like paint and such. Well, they also work really good when you're draining fluid out of a transmission. Anyways, brass filings are our big clue. And then we also want to pay particular attention to the descriptions and the types of parts. So you can see answers A and B are both loose bearings. And answer C is worn rings, blocker rings. And D is broken input shaft gear teeth, broken teeth. So when you see loose and loose, don't just think, all of these options are loose, or all of these are worn, or all of these are broken. You got to go slow enough to make sure you get all the information found in the question, such as the brass filings, and then accurately read the descriptions in the answer choices, because literally the difference between loose, worn, and broken can make a big difference when you're going through your choices for answers. So here's the inside of a manual transmission. Hopefully, if you're preparing for this test, you are already aware of this. But this is what the inside of a manual transmission looks like, starting clear out here with the nose and the pilot bushing or bearing, clutch disc, input shaft. We have the front main shaft bearing, rear main shaft bearing. Same thing, we have the counter shaft with bearings on each end. And then we have the various components in the middle, the various gears, okay? So if we're looking at this, and remember we're talking about brass filings. While I've been talking, hopefully you've been looking over this image. Let me even make it a little bit larger. Hopefully you've been looking over this image, and there's really, from what I see, only about 5 places that brass jumps out to me. We see it down here, and then here, and then here, here, and here. That's the only place I see anything in this image that looks like brass to me. Okay, so what we're looking at there, that's the blocker ring. It's part of the synchronizers, and they're used so that when changing gears and engaging the collar with the shift fork, that the brass can slide up against the ring, okay, the cone. Should move my highlighter over here against the cone, and in doing so, it creates some friction there and allows the two shafts, okay, the two gears, if you want to think of it that way, to match speed, so then it can be engaged without grinding. Okay, if you're not familiar with how synchronizers work, you would definitely want to study up on them before taking this test, or get in touch with a trainer like me for some individual personalized type training in the various areas that you might find that you're weak as we go through these. So again, brass filings is our big clue. And so the only one of these really that would make any sense for brass is those worn blocker rings. So that would be your correct answer. Okay. Most of these other items, if they were, well, just loose, could be a number of causes for that besides wear, maybe not shim correctly, or a number of different things. And then broken gear teeth would probably be pretty obvious if you have teeth of gears coming out with the fluid. So here, question 2 is a little bit different. We have a Tech A, Tech B type of question. Well, our first question, question 1, was just your typical multiple choice, right? We've all seen it 1,000 times growing up through school and so on. But ASE loves these Tech A, Tech B type questions. Let me read through the question and the answers, and then I'll give you some tips on these types of questions. So question 2, a manual transaxle makes a clunking noise on acceleration and on deceleration. Technician A says that a loose differential case pinion shaft could be the cause. Technician B says that a worn clutch release bearing could be the cause. Who is right? And then your choices are only Tech A, only Tech B, they're both correct, or they're both wrong. Okay? Now let's talk about these questions a little bit. Anytime you have a Tech A, Tech B question, for some techs I've trained, it's helpful to just think of them as actual names. So I'm a middle-aged white guy, so Adam and Bob, right? But whoever, if the whole Tech A thing and Tech B thing drives you nuts or bothers you, come up with a name that starts with A and a name that starts with B, and just substitute it in there. Like for me and Adam, I would just simply say, Adam says that a loose differential case pinion shaft, and Bob says that a worn clutch release bearing. If that makes it a little bit more relatable to you, that's one technique you can use that maybe be helpful. The other thing to point out is the tricky thing they do with these Tech A, Tech B questions is they're actually giving you 2 questions inside of one question, and they're both true or false. You're basically saying, is Tech A correct? True or false? Is Tech B correct? True or false? Then once you have both answers, you're then able to make your selection and move on in the test. Okay? Let me also back up to that slide real quick. I also want to talk about, we're talking about a transaxle. Whenever you see transmission or transaxle, make sure you pay attention to that when answering a question. The big difference is a transmission is going to be on your typical traditional layout, engine in the front, transmission behind that, then either drive shaft or transfer case and then drive shaft and then out to the rear end, right? When they're talking about a transaxle, that means that it's a transmission that also has the differential assembly as part of the entire component. And then just like I mentioned on question 1, make sure to pay attention to the bits of information. It's specifically a clunking noise, okay? So that's different than a rattle or a squeak. This is a clunking noise. And then also when it's happening, acceleration and on deceleration, okay? So technician A is blaming loose differential case pinion shaft. Technician B is blaming worn clutch release bearing. So what do we think? Is either one of them right or wrong? Or are they both right or are they both wrong? I had to look high and low and scour the internet from one end to the other, and I finally ended up with this image to share with you. The original image is on the far left of your screen of a transaxle, okay? And this is, the transmission is to the rear of this, and you can see the input shaft comes in, goes over the top, through the transmission, which would be off the edge of the illustration, and then comes back here to the pinion that then this differential ring gear engages, and that's how it sends power left and right out to the wheels. So the middle image and the far right image are just blown up in large parts of that image that's on the left of your screen. And so this is what the one tech is saying could be it, the differential pinion, okay? So let's move on here and find out that only A is correct, because the loose differential pinion case shaft could cause a clunking noise, okay? But technician B is way off base, because the clutch release bearing, also known as a throwout bearing, would not be it wouldn't be involved in the process or being affected during acceleration or deceleration. It would be, if it's causing a noise, it would be when the clutch is disengaged or in the process of disengaging the clutch. Okay? So again, 2 true or false questions. Figure out your answer for A, figure out your answer for B, and then the combination of those 2 is how you get to actually answer one of these questions. All right, question 3. A front-wheel drive vehicle has a vibration only when cornering. Which of these could be the cause? An out-of-bounds tire, a worn CV joint, a worn ring gear, an out-of-bounds axle shaft. Okay, so excuse me, our big hints here is front-wheel drive, and that we're talking about a vibration, and that only it occurs when cornering. So front-wheel drive typically means we're dealing with a transaxle, even though they didn't state it in the question. And only when cornering, another way to say that would be not when driving straight. So again, take that information from the question and figure out what you can derive from it, what additional things that you can know from what they're telling you, okay? Such as, okay, transaxle and not when straight. The question doesn't say that, but we can derive that from reading all of the information carefully in the question. So, a lot of times when going through these, even if you're not sure about a worn CV joint, and we'll talk about that in a minute, and I'll show you a picture of what they're talking about and as far as what a CV joint is if you're not familiar. But now as you're going through your answers, decide, well, would this answer even make sense? I've highlighted only when cornering. So let's look at answer A here. Well, an out-of-bounds tire certainly could cause a vibration. It'd probably happen at higher speeds, like highway speeds, but it would always be an issue, right? Whether cornering or not. And then answer C, a worn ring gear. Well, the same thing. It would always be an issue, okay? If it's a transaxle and it has a worn which means it has the differential included in it, and the ring gear is worn and it's having issues engaging the pinion, well, it would always be an issue, not just when cornering, because it didn't say like worn spider gears in the differential part. It says a worn ring gear. And then answer D, same thing, an out of balance axle shaft. Well, it's going to be out of balance whether the vehicle is cornering or going straight, okay? So this is what they're talking about with a CV joint. Just anytime in ASE's tests, when they're saying a CV joint, they're typically going to be referring to the ones that are on a front-wheel drive vehicle or on the front axle of an all-wheel drive vehicle. And that's the joint that's inside of this boot here. There's one on each end, one at the transmission end, one out at the wheel end. And this joint is what allows the front wheel to be turned, but still have power applied to it. We can see that this is a strut type setup in this illustration. So up on the top of the strut, we'd have a turning plate. And then we have the lower ball joint down here. And that's how this vehicle can turn, is by pivoting on those 2 points and still have power going to the wheel because of this constant velocity joint. Now, there's different types of constant velocity joints. So if you're not familiar with them, you would want to study the different types of constant velocity joints that are inside this boot. I won't go into that depth during this introductory practice test questions video. So we are derived, even by process of elimination, which is one of the techniques you can use, that even if you weren't certain on all of these answers, or just immediately reading this question, always read the whole question, always read every answer. And if you did that and you jumped through this, and maybe this is one of your 15-second questions, and boom, you were right on B, but maybe you weren't for sure. Well, I just demonstrated a way to go through process of elimination and just think about each potential offering in terms of the answers. Will an out-of-balance tire change only when it's cornering? It doesn't say that it's a slipped belt or anything like that. It says it's just simply incorrectly balanced. All right, question 4. Using the illustration shown, the technician is measuring pinion bearing, and then we're going to fill in the blank here after that colon. So is the technician measuring backlash, run out, preload, or depth? Okay. Again, make sure you read the whole question, because if you just stopped at the word pinion, then you miss the word bearing. The word bearing makes a big difference in the answer for this question. Okay, because when you're measuring pinion, well, yes, you can measure backlash, with the, typically we would call it ring gear backlash. You can measure run out in some ways. Preload, though, applies to the bearing. Okay, so you see again where process of elimination. And then depth. Okay, well, yes, there's such a thing as setting the pinion depth, but we're talking about the bearing. Which bearing? Well, yes, it's the bearing for the pinion, one of them, okay? But make sure how these apply, and that you read all of the information and not just answer this based on pinion. And then also look at your image carefully here. We see the pinion yoke, but we do not see it being held. And then we see an inch-pound torque wrench. Okay, and the technician just using their thumb and forefinger, so inch-pound torque wrench, and the technician is not, gripping it with full hand, and we're also not holding the yoke. So obviously this is not an illustration of torquing the pinion nut, right? So no, no, and no as far as A, B, and D, because the only thing this technician could be doing to the bearing would be setting the preload. Okay, so correct, the pinion nut is tightened to a preload the bearing, and you usually have a starting point, and then you check it, and if it turns too easily, Then you add some more turning to the nut, and not like a whole turn, but just a little bit. So then that's when you would hold the yoke, actually tighten or torque the nut a little bit more, then measure it again with that inch-pound or micronewton torque wrench. Question 5. Which of these is the technician measuring in the illustration shown? And for the sake of this presentation, I made this as big as I could. The image in the study guide, the picture is not quite that big in relation to the text, but hopefully you can see here. And in my next, let me jump to my next slide. I have an arrow. Okay, so which of these is the technician measuring in the illustration shown? Side gear clearance, ring gear runout, pinion depth, or bearing preload. Okay, so based on what we talked about in the previous question, again, don't use any of the statements from the previous question towards this question, but just using some of the things I talked about in terms of the pinion, would we think that this technician is measuring preload or pinion depth or ring gear runout? Okay, because what we see here is one of those bundle, the stacked types of feeler gauges where you can flip through the different sizes until you get to the one that fits in between two objects that you're measuring the gap in between. And you have to look very closely that this technician has it slipped in here behind this gear. Okay, so does it look like we're measuring preload? Are we anywhere near the pinion? And would we be measuring ring gear runout? Well, all of those would be no's, because for ring gear runout, we would use a dial indicator. For pinion depth, we would be putting marking paste here on the ring gear, rotating it through, and then reading the paint to see where it's being wiped off as it's passing past the pinion. And bearing preload, well, I already talked about bearing preload in the previous question, and you even saw an illustration of how that would be measured. So we're clearly talking about side gear clearance is what's being demonstrated here. Moving on to question 6. A four-wheel drive vehicle vibrates while the front axle is engaged. Technician A says that a failed rear axle shaft bearing could be the cause. Technician B says that different front and rear tire diameters could be the cause. Who is right? And then we have our typical choices. So you already know that we're dealing with 2 true or false questions here, and we just need to figure out, is A correct or not? Is B correct or not? And then move on with our answer from there. So let's dig into this one a little bit. Okay. Four-wheel drive, and when the front axle is engaged. Okay. I know that some manufacturers kind of mosh up terms, but generally speaking, in the industry and in ASE speak, when we specifically say four-wheel drive, then we're talking about a vehicle, typically a truck or an SUV, that in normal mode of operation operates in two-wheel drive, typically with the rear axle. And then when engaging four-wheel drive, typically either electronically or with a mechanical lever and a transfer case, is when we're then engaging the front axle. Okay, different than all-wheel drive, whereas typically all-wheel drive is more found on SUVs and smaller station wagons, where it engages whenever slippage is detected. It's always there. It's always on, but it's different than four-wheel drive like you would have, say, on an F-150 or a Chevy Silverado or Ram truck. This is usually the way they would talk about a four-wheel drive would be in a truck or even a large, full-size, mid-size SUV, where a normal two-wheel drive operation mode can be selected, and it's usually the rear axle that's driving the vehicle. So there's a little speech on four-wheel drive, all-wheel drive. Just keep in mind to not answer this question with anything assumed, and that it would be potentially a different answer if it was said all-wheel drive. Okay. Technician A is saying the vibration when the front axle is engaged is rear axle shaft bearing. Technician B says different front and rear tire diameters. Hopefully you have your selection by now. And here we go. Hopefully through all of that rambling I did about four-wheel drive and all-wheel drive, you picked up on that Technician A saying rear axle shaft bearing. Well, it would always have that vibration even in two-wheel drive mode, right? So we can already say Technician A or Adam is false, incorrect. Technician B, though, says different front and rear tire diameters. Okay, well, when in two-wheel drive mode, they're not connected, right? They're all on the ground, they're all rolling, but the diameter is going to affect how fast the wheel is spinning. Okay, so a larger tire on the same size wheel is going to go around less revolutions than a smaller tire, right? Picture like a little wheelbarrow tire versus, tire off of Bigfoot or something. Obviously, to roll at 10 feet, that wheelbarrow tire is probably going to go around 20 times, where the Bigfoot tire off of some monster truck is maybe going to go around once. Okay, so hopefully you have your answer now. And that B, Technician B, or as I call him Bob, is correct, because when you then engage that front axle, if the tires are not going around at the same revolutions, it would definitely cause binding through the differentials, the drive shafts, the transfer case, and it can really cause carnage, I'll say. Question 7. A clutch chatters during engagement following a clutch replacement. Which of these could be the cause? You can see we're now back to a typical 4-answer multiple choice type question. Our choices are an incorrect throwout bearing, a bent release fork, stiff clutch linkage, or poor flywheel surface finish. I've added an image here. This is not from the study guide. This is a stock internet image. Just for illustration's sake, and for me to talk a little bit about when we're talking about pressed and depressed and engaged and disengaged, and sometimes the terminology used can get a little weird, okay? So when we're talking about clutch pedal depressed, that means your foot is holding it to the floor, okay? Which that means the clutch is now disengaged. When the clutch pedal is released, as illustrated on the far right side of the illustration, then that is when the clutch is engaged, okay? So we apply the clutch pedal, and if everything's working properly, that's called depressing the clutch pedal, and that's disengaging the clutch, okay? The clutch is engaged, meaning the pressure plate or cover is clamping the clutch disc and transferring power through to the input shaft of the transmission. That is when the clutch is engaged. So just go with those definitions. You may, in your way of speaking, say things a little bit differently, but you have to go with the clutch is engaged when it's capable of transferring power to the transmission. It's disengaged when it's been released by depressing the clutch pedal. And we say depressing because depressing means pushing and holding, okay? So if you just press a button, that means you've applied it and released it. Depressing a button means holding a button, okay? So that's where the terminology and the lingo gets a little weird if you're not used to that. When you depress something, you're pressing it and holding it, so we call it depressed. Move on here. So here's that bigger image. I should have moved to there while I was giving that last little speech. So clutch pedal is depressed, meaning applied. You can see this is a slave cylinder type. So it is extending this rod. We have a fulcrum point here, which is then pushing against the clutch release bearing, also known as a throwout bearing, which is then pushing on the fingers of the pressure plate, also known as clutch cover. and then they flex. They also have a fulcrum point, and that's how we then get the disc, the clutch disc, to be able to freewheel and not be driven by the flywheel. Illustration on the right, the clutch pedal is not depressed. The clutch fork is not being engaged by the slave cylinder, so this would be the relaxed position. We can see that the release bearing is not touching the fingers of the cover, okay? And the clutch disc would be then being clamped between the flywheel and the cover and able to transfer power to the transmission. All right, let's get back to the question. Our big hint from our question is chatters during engagement. So when would engagement be? Engagement is when you've had your foot to the floor on the clutch pedal. That means the clutch was disengaged. That means you're now lifting your foot. Okay, you have the manual transmission in a gear, hopefully first if you're going forward, and you're now raising your foot and you're slowly releasing that clutch pedal. That is the point of, that is when you're engaging a clutch. Again, when you're pushing your foot down, that's when you're disengaging a clutch. A lot of technicians use those terms in all sorts of different ways, but if you're going to take ASE test, you have to go with those definitions that I'm sharing with you. The clutch chatters during engagement following a clutch replacement. Which of these could be the cause? An incorrect throwout bearing. Well, that would be, as I just showed you in the last picture, an incorrect throwout bearing is not touching when the clutch is engaged, right? And the pedal's not pressed or depressed. So when you were then releasing, right, the clutch, disengaging the clutch, in other words, applying the clutch pedal, that's when you would start having a noise from a throwout bearing. Okay, a bent release fork. Well, there'd be an issue with disengaging the clutch and it would be dragging. Okay, you have your foot to the floor on the clutch pedal, fully depressed, but you still can't get it in gear, or the vehicle's still wanting to move because there's still a dragging going on. Answer C, stiff clutch linkage. Well, it would make the pedal harder to depress, right? So that leaves us with D, poor flywheel surface finish. Okay, a poor surface on the flywheel would then cause the clutch disc, as it's starting to get clamped between the cover and the flywheel, it would have inconsistent friction, and that's where that chattering is formed. All right, for our last question, ASE likes to use the except for the last question on their practice test. It doesn't mean that they're going to be on the end of your exam when you take the A3. They'll be strewn throughout, but they're worth, you got to keep an eye out for them. They're probably the trickiest question in my opinion, and the type of question, the way they're worded, that I find with technicians I've trained and worked with have the hardest time with these except. Okay, so I want to give you some tips on these while we go through this last question from the study guide. So just reading the text from ASE, you'll have this at the top of the question. Not every time necessarily, though. This question contains the word except. Read the question carefully before choosing your answer. Okay? So my take on that, when you see the word except in an ASE question, you're going to read a statement that, like I will here in a minute, and then you're going to read through the answers, and you're looking for the three that can cause what they're describing. And there's going to be one that cannot cause what they're describing, and that is your except. That's what they mean by that. The one answer that would not cause what they're describing. So in other words, you need to find the three right answers if you want to think of it that way, and then that's how you will get your except. Okay. These questions, it's important to read all the answers in every question, but especially on these except type questions. Okay. So the clutch does not release fully when the pedal is pushed to the floor. Any of these could be the cause except weak pressure plate springs, too much free pedal travel, a warped clutch disc, a seized pilot bearing. Okay, so on answer B, too much free pedal travel. Couldn't we say that that could cause partial disengagement? Okay, so again, we're looking for the things that could cause it to not release fully. What about a warped clutch disc, right? Well, I think it could allow the disc to still drag on the flywheel. Picture this, you have the clutch pedal fully depressed, meaning applied to the floor and held, okay? Which means then that release bearing, also known as throwout bearing, has applied against those fingers on the clutch cover, okay? Also known as pressure plate. But if that clutch disc that's sandwiched between that cover and that flywheel, if it's all wobbly, okay, it still could be getting some friction against the flywheel and the cover. So that could cause a sensation of not fully releasing. But what about our other two choices? This is one where if you haven't done much manual transmission or clutch work, you might not be familiar with one of your choices. A seized pilot bearing. I'm going to talk about that for just a minute. This is the best illustration I could find for this. Let me see if I can make it a little bit bigger. Yeah. All right, so we're looking at a very basic illustration of the rear of the engine here. And then going off to the right, kind of in ghost fashion, we see then our flywheel, our disc, and our pressure plate, also known as the cover. Then we see the release bearing, also known as the throwout bearing. And then we see the input shaft of the transmission. Obviously, the input shaft of the transmission is splined, passes through the pressure plate, through the hole in the center of it, and engages the disc. And so when the disc is clamped and the clutch is engaged, that's how we get the power from the crankshaft of the engine into the manual transmission. But there's a lot of forces on that clutch. So out here on the very end of that input shaft of the transmission, there's kind of a snout or a nose that sticks off of that. And it passes all the way through everything, and it gets supported by a pilot bearing or bushing. And manufacturers over the years have typically used three different types. Some use a needle bearing in there that's pressed into the end of the crankshaft. Some have used a sealed pilot bearing, probably the most common now in our current age. And then some use a bushing that typically was a brass bushing, and it was what we called oil impregnated. It was brass, so it was kind of porous, and it had been soaked in oil, and it was pressed into the end of the crankshaft. Okay? So the pilot bearing is turning at the same speed. The outer part of it that's pressed into the crankshaft is turning at the same speed as the crankshaft. And when the clutch is engaged, the input shaft of the transmission is turning at the same speed. So the bearing is really just not doing anything because the shaft and the crankshaft, input shaft and crankshaft, are turning at the same speed. But when you then disengage the clutch, meaning apply the clutch pedal to the floor and hold it, the engine is going to keep turning, but you might be sitting at a stop and you might have the transmission in gear. You have the clutch disengaged, again, pedal to the floor. Well, now the end of this transmission, this input shaft, is not turning, but the crankshaft still is. And that's why we need to have a bearing or bushing of some sort in the end of the crankshaft so that we don't burn up the end, the nose, the tip of that input shaft on the transmission. But if that pilot bearing or bushing were seized, it's going to then, through that bearing being failed, going to, regardless of the clutch being disengaged, it's going to still try to apply power into the transmission because of the friction. And if it's left in that condition for very long, it's going to damage that input shaft of the transmission very quickly. So hopefully as I went through all that, you've determined which three can. Okay. Too much Pedal free travel definitely could cause partial and disengagement. Warped disc, I already talked about. The disc could still drag on the flywheel. And then that seized pilot bearing, hopefully I explained that well enough for you to see where it would have the same effect as the clutch not releasing. So A is our accept. A weak pressure plate springs could cause slippage, okay, by not clamping the clutch disc well enough, but it would not cause the clutch to not release. And remember, we're trying to find the accept. Pay close attention to these. I know it's tough. A lot of techs get hung up on these accept. Luckily, they don't throw a ton of them in there, but they are one of the 5 types of question formats that ASE uses. So as we went through all of those, we should have hit, what do we have here? 6 different categories, some a little bit more than others. We only had 8 practice questions, but as we went through those, if there were certain areas here as you look through these that you, when I was talking, you were just, oh man, this is crazy, then that's the area you need to study. Like maybe, for instance, when I was talking about clutches, and if that wasn't making sense or you weren't seeing the answers before I was done talking about them, then that would be an area to study. Or that question that we had about the CV joint causing the vibration when turning. If that one didn't jump out at you as soon as you saw it, you're definitely going to want to do some studying in that area. That's also where I can help. I'm Brian D. Wampler at AutoShopTeacher.com. You can contact me through the website, which will send me an email. My phone number is also on there, and I'm happy to help. Thank you for watching.